Welcome to the Extreme Broadband Engineering Cable 101 training series. In this session, we'll discuss isolation. The learning objectives for this session are: define isolation, understand what isolation is, and review isolation specifications. Let's get started. Isolation is the amount of signal separation that a device has between any two output ports. Here we're showing a two-way splitter with signal feeding from the output ports to the input. Ideally, we'd like all the signal to travel in the direction that it's intended to go, in this case from the output to the input. But some of the signal travels to the other port where it's not intended to go. Isolation attenuates the signals going to the ports it's not intended to go to. Isolation helps to ensure that the signals only travel through the device in the direction they're intended to travel. In this case, we're showing a 2-, 3-, and a 4-way splitter with the return signal flowing from the output to the input. We don't want the signal to flow between the other output ports. But in reality, a small amount travels to the other ports and is attenuated due to the port-to-port isolation. The higher the isolation specification value in dB, the better the isolation. Here we're showing a two-way splitter with isolation specification of 35 dB. 35 dB isolation means that the signal will be attenuated 35 dB from the original signal at the other output port. In this example, we're feeding a 50 dBmV signal into one of the output ports. As the signal passes from this port to the other output port, it's attenuated by 35 dB. On the other output port, the signal is now at 15 dBmV. 50 dBmV in, minus 35 dB isolation, for a signal of 15 dBmV out. There are many different isolation paths within splitters. Here we're showing a two-way splitter and its isolation path from one output port to the other. This path is bidirectional and can flow from either port. Now let's look at a four-way splitter, which has additional isolation paths. From port 1 to 2, and from port 3 to 4, the signal flows to the isolation path of the internal splitters. Another path is from port 1 to port 4. The signal flows through the first internal splitter's insertion loss, through the isolation path of the next internal two-way, and through the insertion loss leg of the next internal two-way splitter. Since the signal flows through the isolation path of one internal splitter and the insertion loss of the other two internal splitters, the isolation loss of this path is greater by 7 dB than from port 1 to 2 or port 3 to 4. Another path is from port 2 to port 4, and another from port 1 to port 3. The isolation path between ports 1 and 2 and ports 3 and 4 will meet the device's isolation specification. The other paths will be better by at least 7 dB due to the flow through the insertion loss of the two additional internal splitters. The input connected to an output port in error will cause low signal on all outputs except the one that's connected to the input. Have you ever seen a connection where the input cable was connected to one of the output ports and the customer was experiencing poor reception on all but one outlet? One outlet has good signal level, as this one's connected to the input port of the splitter, and the signal will flow from the output to the input with normal insertion loss of the splitter. The other outlets have poor signal level due to the isolation loss of the splitter. Once the input cable is connected to the input port, all outlets will receive the proper signal. Let's take a look at isolation specification sheets. Here we're showing a specification sheet for a broadband digital splitter series, which includes the two-way, three-way, three-way balanced, and four-way splitters. On the left-hand side is the column labeled frequency. Here we break the frequencies into 7 different bands, starting with 5 MHz, going up to 1 GHz. Next to that is a column labeled min-max. These are the worst-case isolation numbers for these devices. These numbers are normally used by the engineers and designers of cable systems. Next to that is a column labeled typical. These are the specification numbers that you would typically see from the majority of these devices in the field. The higher the isolation specification value in dB, the better the isolation. One area to make note is the specification in the 16 to 40 MHz bands. Here the isolation specification is better by 5 dB. Typical signal levels feeding these devices in the forward are in the mid-teens to low 20 dBmV range. On the return, the typical signal range from cable modems is much higher, around 35 to 55 dBmV. The higher isolation at these frequencies lowers the potential for these high levels interfering with other port signals. Let's review what we've learned in this training session on isolation. Isolation is the amount of signal separation that a device has between any two output ports. Isolation helps ensure that the signals only travel through the device in the direction they're intended to travel. The higher the value of the isolation specification, the better. Thank you for viewing this training on isolation. For additional training topics, see our website at www.extreme-broadband.com.